Hi, today we are going to see Duobinary coder problems in digital communication, and this is Manila. So Duobinary signaling system is used to double the transmission capacity of a straight binary system. So first we will see the Duobinary without precoder. So here the input binary sequence BK is given to the pulse amplitude modulator, so which is used to make it into a three pulses here, that is voltage here. So as minus 1 for 0 and then plus 1 for 1. So 0 for 0 data sequence the value is assigned as minus 1, and for 1 the value assigned is plus 1, and then sorry plus 1 volts. So then after converting into an AK, we are going to give you a Duobinary conversion system, which it will convert this plus 1 minus 1 as a minus 2 volts 0 and then plus 2 volts. So it is converted and then we will be giving it a value of CK. So in the receiver, so we'll be converting this CK in terms of your voltage, and then the things can be converted into a data sequence by using your decision algorithm. So let's see how to solve the problems in this Duobinary without precoder. So the binary data sequence they have given, apply to an input of a Duobinary coder, find the corresponding receiver output. So here they have given your data sequence. So the data sequence is an 8-bit. So 0 to 7 we have taken. Okay, and then in the previous block diagram we saw first we'll be getting your data sequence BK, that will be converted into a AK and AK minus 1, that is your uh, AK is nothing but converted into a voltage level, that is plus 1 and then minus 1. Then with the delay element we will be having your AK minus 1. Then we will be having your CK. So doubling your value of your AK. So the CK is transmitted and then will be receiving at the receiver end. This AK will be received at the receiver end and will be retrieving your voltage here, and then that from that voltage will be connected, finding our binary sequence. This based upon the decision algorithm. If your AK that you have received is minus 1, then the data sequence is 0. If it is plus 1, the data sequence is 1. So this is how the problem goes. Similar to that of the block diagram we saw in the previous slide. So I have given the data sequence 00110100. Then AK converted, so 0 is to, you have to allocate minus 1 for 0 and then plus 1 for 1. So this is your AK in volts. So 0 is minus 1, 0 is minus 1, plus 1, plus 1, minus 1, plus 1, minus 1, minus 1. Then AK minus 1 will have one shift, one delay. So this will be moved to this place. Then this place will have one shift. So after shifting it, we got your AK and AK minus 1. So with the help of this, we can get your CK. So CK is the first value will be given as such because we don't have any delay element for the first. So your CK will be minus 1. So minus 1 plus minus 1 is minus 2. Minus plus 1 minus 1 is 0. Again plus 1 is plus 2. Minus 1 plus 1 is 0. Plus 1 minus 1 is 0. Minus 1 plus 1 is 0. Minus 1 minus 1 is minus 2. Now we will be transmitting this signal from the transmitter side. So we will be receiving the receiver side. From that receiving sequence, we are going to get your A cap. So how to get your A cap? CK minus your AK minus 1. So here first one you don't have AK minus 1, so you will get your same data. So here minus 2 minus of minus 1. It's like minus 1. The 0 minus of minus 1 becomes plus 1. Plus 2 minus of plus 1 is plus 1. 0 minus of plus 1 is minus 1. 0 minus of minus 1 is plus 1. 0 minus of plus 1 is minus 1. Minus 2 minus of minus 1 is going to be minus 1. So based upon this sequence, we are going to get a binary sequence. So if your value or AK is minus 1, the value is going to be 0. If it is plus 1, it's going to be 1. So it's going to be 0, 0, 1, 1, 0, 1, 0, 0. So this is the transmitted data here. That is the data sequence at the transmitter section. This is the detected sequence at the receiver end. If both are the same here. So we'll see if any error has been occurred here, then automatically what happens, that error will be propagated throughout the system. So to avoid this one, we'll be connecting our precoder before the transmitter section here. So this is your precoder. So here what happens, if both the things are same, we'll be using a modular adder. So this data sequence BK will be converted into a DK. So we'll be having a modular adder. So in this modular adder, if two inputs are different, you'll be getting your output. Else it won't. So to avoid the error, I'll be getting a decay again similar to that of your previous one. So we'll be converting into a voltage sequence. Then we'll be giving into a Duobinary conversion filter, that is the AK, and again we'll be having one delay version. Then we'll be getting your output sequence. So at the receiver end, we'll be receiving the data sequence, then we'll be rectifying it out, and then we'll be getting a decision device depending upon the value. So if your modulus of CK is less than 1, the value of data bit sequence is 1. If your CK is greater than 1, then your BK is going to be 0. So now we'll solve one problem. So the binary data sequence, they have given a sequence is applied to input Duobinary coder. Find the corresponding receiver output. Here you are going to assume your pre-order. Normally assume your pre-order means we'll be assuming it as 1. So here as per the block diagram, we'll have your AK, we'll have your pre-coder, right? So DK is your pre-coder. The formula for your DK is BK plus DK minus 1. So this plus is nothing but your modulo 2 addition, and then the delayed version will be given here. So now we'll be performing the two level sequence. So what is the two level sequence of DK? Two level sequence of DK minus 1. Then we'll get your CK with the formula DK plus DK minus 1. We'll be transmitting the CK, and then at the receiver, depending upon your CK, you will be retrieving your data with your decision algorithm. If modulus of CK is less than 1, the value is 1. If your modulus of CK is greater than 1, the value is 0 here. So now we'll get your data sequence here. So I'll be taking the data sequence from 1 onwards. So 0, 0, 1, 0, 1, 1, 0. So 7 sequence. So 0 to 0, 0, 1, 0, 1, 1, 0. So now I'm going to assume this pre-order. So this coding, this 2 is for your pre-coder, right? So precoder we have to perform the modulo 2 addition. So I'll be assuming my first value 1. Always assume the 1. So this 1 will be transferred to this area here. So now after getting this one, I'll be getting your DK. What is the DK? DK modulo 2 addition of your DK minus 1. So this is your BK modulo DK minus 1. So 0 plus 1 is going to be 1. And then so modulo 2 addition means what happens? So 0 plus 0 is going to be 0. 0 plus 1 is going to be 1, 1 plus 0 is going to be 1, and 1 plus 1 is going to be 0. So this 1 will be shifted to this place. So 0 plus 1 is going to be 1, shift the 1, 1 plus 1 is going to be 0, shift the 0 here, 0 plus 0 is 0, shift your 0 here, so 1 plus 0 is 1, shift your 1 here, so 1 plus 1 is 0, shift your 0 here, so 0 plus 0 is 0. So now I got the DK. So I got DK minus 1. That should be converted into a 2-level sequence. So what is this 2-level sequence? If the value is going to be 1, it's going to be plus 1. If your value is going to be 0, it's going to be minus 1. So what you will get here? So this is we are not going to bother about this one. Here alone we are going to take. So DK, the value is 1, so it's going to be plus 1. So it's going to be plus 1, minus 1, minus 1, plus 1, minus 1, minus 1. So DK minus 1, this is your DK minus 1. So same thing. So plus 1, so plus 1. Here it is plus 1. Here it is 0. So minus 1. Again 0 minus 1. Plus 1 and minus 1. So now we are going to get your CK formula is DK plus DK minus 1. So 1 plus 1 plus 1 is going to be plus 2. Plus 1 plus 1 is going to be plus 2. Minus 1 plus 1 is going to be 0. Minus 1 minus 1 is going to be minus 2. So this is 0, 0, minus 2. So now this is the CK that we are going to transmit from the transmitter end. So while receiving the receiver end, we are going to use your decision device. So modulus of CK should be less than 1, now the value is 1. So it is modulus of ck is greater than 1. So it's going to be 0. It's greater than 1, 0. It's less than 1. So it's going to be 1. It's going to be greater than 0. Modulus, right? So greater than 1. So the value is 0. Less than 1. Less than 1. Greater than 1. So this is the data that will be at the transmitter end, and this is the data at the receiver end. So both are same. Thank you guys. Have a nice day. Subscribe my channel for more.